Section 23 of the Science History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Pamela Nagami. The Science History of the Universe, Volume 1. Edited by Francis Rolt-Wheeler. Astronomy. Chapter 15, Part 2. Mars. The visual observations of Professor Lowell have been undertaken with great thoroughness and have brought to light such material which he has employed in the development of his theories. To do justice to his work in a single chapter is manifestly impossible. It will be most satisfactory to the reader to recapitulate in Professor Lowell's own words, derived from his work on Mars and its canals, the fundamental facts which he has recorded and on which he bases his conclusions. They are as follows. Number 1. Mars turns on its axis in 24 hours, 37 minutes, 22.65 seconds with reference to the stars, and in 24 hours, 39 minutes, 35 seconds as a mean with regard to the Sun. Its day, therefore, is only about 40 minutes longer than ours. Number 2. Its axis is tilted to the plane of its orbit by about 23 degrees 59 minutes. Most recent determinations of 1905. This gives the planet seasons almost the counterpart of our own in character, but in length nearly double ours. For number 3, its year consists of 687 of our days, 669 of its own. Number 4. Polar caps are plainly visible, which melt in the Martian summer to form again in the Martian winter, thus implying the presence of a substance deposited by cold. Number 5. As the polar caps melt, they are bordered by a blue belt, which retreats with them. This excludes the possibility of their being formed of carbon dioxide, and shows that of all the substances we know, the material composing them must be water. Number 6. In the case of the southern cap, the blue belt has widenings in it in places. These occur where the blue-green areas bordering upon the polar cap are largest. Number 7. The extensive shrinkage of the polar snows shows their quality to be inconsiderable and points to scanty deposition due to dearth of water. Number 8. The melting takes place locally after the same general order and method, Martian year after year, both in the south cap. Number 9. And in the north one. This is evidenced by the recurrence of rifts in the same places annually in each. The water thus let loose can therefore be locally counted on. Number 10. That the south polar cap is given to greater extremes than the north one implies again, in view of the eccentricity of the orbit and the tilt of the axis, that deposition in both caps is light. Number 11. The polar seas at the edges of the caps being temporary affairs, the water from them must be fresh. Number 12. The melting of the caps on the one hand and their reforming on the other affirm the presence of water vapor in the Martian atmosphere, of whatever else that air consist. Number 13. Since water vapor is present, of which the molecular weight is 18, it follows from the kinetic theory of gases that nitrogen, oxygen, and carbonic acid, of molecular weights 28, 32, and 38 respectively, are probably there too, owing to being heavier. Number 14. The limb light bears testimony to this atmosphere. 15. The planet's low albedo points to a density for the atmosphere very much less than our own. Number 16. The apparent evidence of a twilight goes to affirm this. Number 17. Permanent markings show upon the disk, proving that the surface itself is visible. Number 18. Outside of the polar cap, the surface is divided into red ochre and blue-green regions. The red ochre stretches have the same appearance as our deserts seen from afar. Number 19. And behave as such, being but little affected by change. Number 20. The blue-green areas were once thought to be seas, but they cannot be such because they change in tint according to the Martian season, and the area and the amount of the lightning is not offset at the time by corresponding darkening elsewhere. 21. Nor by any augmentation of the other polar cap or precipitation into cloud. It cannot, therefore, be due to shifts of substance. 22. Furthermore, they are all seamed by lines and spots darker than themselves, which are permanent in place, so that there can be no bodies of water on the planet. 23. On the other hand, their color, blue-green, is that of vegetation. This regularly fades out, as vegetation would, to ochre for the most part, but in places changes to a chocolate brown. 24. The change that comes over them is seasonal in period, as that of vegetation would be. 25. Each hemisphere undergoes this metamorphosis in turn. 26. That it is recurrent is again proof positive of an atmosphere. 27. The changes are metabolic, since those in one direction are later reversed to a restoration of the original status. Anabolic as well as catabolic processes thus go on there. That is, growth as well as decay takes place. This proves them of vegetal origin. 28. The existence of vegetation shows that carbonic acid, oxygen, and undoubtedly nitrogen are present in the Martian atmosphere, since plants give out oxygen and take in carbonic acid. 29. The changes in the dark areas follow upon the melting of the polar caps, not occurring until after that melting is under way. 30. And not immediately then, but only after the lapse of a certain time. 31. Though not seas now, from their look, the dark areas suggest old sea bottoms, and when on the terminator appear as depressions, whether because really at a lower level or because of less illumination is not certain. 32. That they are now the parts of the planet to support vegetation hints the same past office, as water would naturally drain into them. That such a metamorphosis should occur with planetary aging is in keeping with the kinetic theory of gases. 33. Terminator observations prove conclusively that there are no mountains on Mars, but that the surface is surprisingly flat. 34. But they do reveal clouds, which are usually rare and are often, if not always, dust storms. 35. White spots are occasionally visible, lasting unchanged for weeks in the tropic and temperate regions, showing that the climate is apparently cold. 36. But at the same time proving that most of the surface has a temperature above the freezing point. 37. In winter, the temperate zones are more or less covered by a whitish veil, which may be hoarfrost or may be cloud. 38. A spring haze surrounds the north polar cap during the weeks that follow its most extensive melting. 39. Otherwise, the Martian sky is perfectly clear, like that of a dry desert land." End quote. These facts, according to Professor Lowell, make reasonably evident on Mars the presence of, number 1, days and seasons substantially like our own; number 2, an atmosphere containing water vapor, carbonic acid, and oxygen; number 3, water in great scarcity; number 4, a temperature colder than ours, but above the Fahrenheit freezing point, except in winter and in the extreme polar regions; number 5, vegetation. End quote. While all of Professor Lowell's observations and results are not accepted by all astronomers, and there is considerable opposition to his conclusions, nevertheless they are of interest and worth stating as representing this aspect of the matter in his own words. Comparative studies of lunar and Martian spectra made on the summit of Mount Whitney in September 1909 by Campbell of the Lick Observatory seem to preclude the possibility of much water on Mars. Campbell's photographs show that the Martian atmosphere is no richer in water than the Moon's, which, if true, summarily disposes of Martian life. Slipher of Lowell's staff claims to have obtained ample spectroscopic evidence of water. The following paragraphs, taken from the concluding chapter of Lowell's book on Mars and its Canals, may be said fairly to sum up his views on Martian life. Quote, "That Mars is inhabited by beings of some sort or other we may consider as certain as it is uncertain what these beings may be. The theory of the existence of intelligent life on Mars may be likened to the atomic theory in chemistry, in that in both we are led to the belief in units which we are alike unable to define. Both theories explain the facts in their respective fields, and are the only theories that do, while as to what an atom may resemble we know as little as what a Martian may be like. But the behavior of chemic compounds points to the existence of atoms too small for us to see, and in the same way the aspect and behavior of the Martian markings implies the action of agents too far away to be made out. One of the things that makes Mars of such transcendent interest to man is the foresight it affords of the course earthly revolution is to pursue. On our own world we are able to study only our present and our past. In Mars we are able to glimpse in some sort our future. Different as the course of life on the two planets undoubtedly has been, the one helps, however imperfectly, to better understanding of the other." End quote. The views expressed by Professor Lowell in the work just quoted were further developed by him in the course of a few years succeeding its publication, and in Mars as the Abode of Life, published in 1908, he expresses himself even more firmly convinced that Mars is inhabited by a race of intelligent beings. Additional study of Martian phenomena, according to Professor Lowell, indicates that the canals and oases, as he sees them, are proof that life of no mean order of intelligence prevails on the planet. He suggests, quote, "Part and parcel of this information is the order of intelligence involved in the beings thus disclosed. Peculiarly impressive is the thought that life on another world should thus have made its presence known by its exercise of mind. That intelligence should thus mutely communicate its existence to us across the far stretches of space, itself remaining hid, appeals to all that is highest and most far-reaching in man himself. More satisfactory than strange this, for in no other way could the habitation of the planet have been revealed. It simply shows again the supremacy of mind. Men live after they are dead by what they have written while they are alive, and the inhabitants of a planet tell of themselves across space, as do individuals athwart time, by the same imprinting of their mind." End quote. To this he adds the statement that conditions for life on the planet are approaching an end, as it is rapidly drying up, and that the energies of the inhabitants are being the slowly diminishing supply of water. Quote, "The drying up of the planet is certain to proceed until its surface can support no life at all." End quote. So that as compared with the Earth, Mars presents a distinctly later period of evolution. No such danger at present confronts our own planet, but assuming that these explanations are correct, it is not improbable that the cooperative action of all the nations of the world may be required at some future date to deal with a similar problem. In opposing the idea of canals on the surface of Mars, much stress has been laid on the alleged fact that the finer markings and some of the apparent doublings are based upon optical illusions or psychological phenomena. Thus, to prove that instinctively the eye would arrange in the form of straight lines vague suggestions of markings, E.W. Maunder of the Greenwich Observatory, England, and J.E. Evans of the Royal Hospital School at Greenwich in 1902 performed an experiment with a number of schoolboys. A circular disc was exhibited 5 or 6 inches in diameter, on which were represented with some accuracy the shaded area of the planet as it might appear in the telescope. Instead of canals, a few faint wavy lines and a larger number of faint dots were inserted promiscuously. The boys were told to fill in with pencil, on small circles on sheets of paper, the details of the object exhibited to them, exercising as much care as possible. The object of the experiment was not communicated to the boys. None of them had any idea of the nature of the planet's surface. The result was that boys at the greatest distance from the object, where the faint lines and dots were just beyond the limits of separate visibility, drew canals remarkably like those noted by the telescopic observers of the planet. Hence it was supposed that the eye in some way integrated such faint stimuli as irregular scattered dots and faint wavy lines into straight lines which have no objective existence. Much has been made of this test, but it may hardly be called conclusive, for Flammarion, when repeating the experiment with French boys, was unable to secure in their sketches lines resembling canals. Moreover, photographs taken during the opposition of 1905 at Flagstaff bring out a large number of the more prominent canals as straight lines. It is possible that psychology plays an important part, and Professor Andrew Ellicott Douglas of the University of Arizona, who has had opportunities to observe the planet at several favorable oppositions, believes the subjective phenomena have much to do with Martian observations. He says, quote, "One may confidently say that such realities do exist, but with the very faint canals, whose numbers reach occasionally well into the hundreds, discordance reigns supreme, and it is frequently found that different drawings by the same artist antagonize each other across the page. Considerations along these lines led me to study seriously the origin of these inconsistent faint canals by the methods of experimental psychology, and the application of these methods has resulted in a new optical illusion and new adaptations of old and well-known phenomena." End quote. The most important of these phenomena was the halo effect, where secondary images are produced under unusual conditions, which images affect the minute details of the surface. Professor Douglas also found that the irregular refraction of the eye produced apparent rays as from a small spot, which could be obviated in part by changing the position of the observer's head. Quote, "The ray illusion," he says, "is to me a very satisfactory explanation of many faint canals radiating from those small spots on Mars called lakes or oases. The only objective reality in such cases is the spot from which they start." End quote. Referring again to the halo, he reaches the conclusion that, quote, "The halo with its light area and secondary images accounts for details which have no objective reality, such as bright limbs of definite width, canals paralleling the limb, or dark areas, numerous light margins along dark areas and light areas in the midst of dark, abundantly exemplified in Schiaparelli's map of 1881 and 1882. Professor Lowell, it must be said, has the unique advantage, or misfortune it may be, to see canal-like markings that are not visible to other astronomers. Thus on Venus he saw bands or lines which he considered bore a superficial resemblance to the canals of Mars, and were apparently permanent and not due to clouds. Again, he claims to have seen lines resembling canals on the third satellite of Jupiter, which others have failed to recognize. Hence many astronomers believe that he is predisposed to see such phenomena. Furthermore, canal-like appearances have been noted on the surface of the Moon by Professor W. H. Pickering as radiating from the central peaks of the northwestern slopes of the central mountain range of the crater of Eratosthenes. He observed two canals which in a small telescope appear straight, yet when seen with a large glass present considerable irregularity of structure. Other and new branches or canals were also seen. In various parts of the same crater, but especially in the southeastern and northern portions, numerous small canals and lakes present themselves. These markings are practically identical in appearance with those seen upon the planet Mars. They are too small to be well shown on photographs, and seem to be of much more regular structure than the larger markings which are also called canals. It is possible that this difference is due merely to the fact that the larger markings are better seen. There can be no free water on the Moon's surface, hence any canals with flowing water are quite out of the question. Yet the appearance is vouched for as remarkably similar to that on Mars by an observer who knows the surfaces of both bodies. End of Section 23.